Good morning. Welcome to the Materials Characterization and Processing Facility Town Hall. I'm absolutely flabbergasted and delighted to see so many people filling the room. It speaks to the interest in having this kind of facility that is now going to actually appear on campus. And I'm really excited for the kind of discussions that we're going to have today. And I'm also excited to show you the progress of laying a foundation for this kind of facility on campus. And actually, that's really the first thing I want to do is emphasize that this is a part of a longer-term strategic process, and we are setting a foundation for developing facilities here on campus, especially with regards to materials characterization and processing. But we haven't, well, I mean, certain things are set in stone, like buying the Steve building and a lot of the foundational principles, but many of the things that we're doing, we're looking for engagement from the larger Johns Hopkins community for input to see how this evolves and make sure that it is optimally useful for the largest community of researchers here at the school. I think I have an automatic, advancer, so. No, it's okay, I'll just this is old school. Thanks. I'm not sure I have another. So with that, let me actually begin rather than with architectural plans, just some of the values that have been used as we've developed this concept and sold it to the Board of Trustees and things like that. So the values of what we want to do is use this kind of facility to attract and retain the highest quality faculty and students at the school, provide novel educational opportunities and the most advanced training for our students at all levels, from the undergraduate to the graduate level. We want to bring together researchers into an interdisciplinary community from across all our schools, centers, and divisions. We have aspirations for helping Baltimore economic development. The location of the Steve facility is right off of 83, makes it particularly amenable to that kind of activity. And we want to be able to use this kind of facility to facilitate, that's what facilities, same root, right? To engage in partnerships with other academic institutions, national labs, things like that, to help our collaborative infrastructure here and globally and internationally. So if the materials characterization processing facility idea is new to you, let me quickly introduce you to it. The MCP is envisioned as a hub for interdisciplinary materials research and characterization, and as a foundation, it will include a suite of advanced tools to process and examine materials from the macro scale to the atomic scale. Housed in 18,500 square feet of the Steve Silver building, relatively recently purchased by the university, right near campus. The MCP will include advanced materials processing and characterization tools, as well as office and meeting spaces, such that if you want to have a workshop or things like that, or teach a class, this is the kinds of place that you could do it. And one of the things that will separate us from the pack, in a sense, is that we will be integrating all of the tools at the MCP with high-speed computation, high-performance computational and machine learning resources. You know, in a pragmatic level, that means high-speed data lines connected directly to Marcy, but we also have aspirations of using this kind of integration to promote the next sort of generation of, I believe Mitra is going to use the word intelligent microscopy to facilitate knowledge gathering, etc. So those of you who don't know me, I should have introduced myself. I'm Jonah Erlbacher. I'm chair of the Material Science and Engineering Department. I have been helping develop the MCP concept for a number of years into its current incarnation. So the first question that people, if you're not really familiar with the area, is where is the Steve Silver building in relation to campus? So the Steve Silver building is right on the, to the southwest of campus. Here's Mason Hall. The Whiting School of Engineering administrative offices are here. Up here is the physics department and chemistry in this part of campus. But it's within sort of the global general region. Down here is our house, which is a great place to have lunch after this, if you like. But because it's slightly off campus, let me just address up front the concerns that everybody has with regards to the Steve Silver building, in particular safety and logistics, lighting. So let me emphasize, and while this is not my specific job, the university is very sensitive to security concerns, and dealing with these and handling these have been at the very highest point in the to-do list from day one. And the Steve Silver building will be have some modifications to its exterior area in order to increase lighting. There is parking there. There is a shuttle that is already in place that leaves, I believe, from Mason Hall every 20 minutes or so to take you to the Steve Silver building if you don't want to walk. And so these are, and it is really being seen as integrated within the university, not a separate facility slightly off of campus. So we appreciate everybody's concerns in this, and if you have specific concerns, we also definitely want to hear about them. Just as a teaser, I'm giving a little bit of an introduction. After my introduction, Ken Livy is going to talk about some of the equipment we currently have in the facility, and then we're also going to introduce Mitra Tahiri. Hi, Mitra. And where's Ken? Ken, next to Mitra. Ken has been really instrumental in helping set this up. Mitra is a new faculty member in the Department of Material Science, officially joining our faculty in January 1st. She will be acting as director of the MCP when she arrives. It's been very helpful in helping direct the vision of this. This is the Steve Silver building. This is the old building that I showed a picture of. This is the so-called 1970s building, which is off to the, which is over here to the left of the old building. And the MCP will occupy this kind of footprint, and we'll get a nice walkthrough of this from the architects from EYP who are working on this concept. A nice 3D picture of it. The idea is actually you'll probably enter through an elevator stairwell into the MCP. This is a classroom area. There's offices. There's areas for seating and a huddle, and then there's sort of a public corridor toward the back of the building. Those people who are using the facilities in the rear of the MCP will be integrated into those. We'll create a nice community. The idea is to create a nice community of people working in that. We'll hear more about that. So like I said, let me introduce the leadership again, Mitra and Ken, Director of Operations. We also have technical and administrative staff. Currently, the MCP is being administered through the Department of Material Science and Engineering. The goal is to eventually spin it off as a separate business unit within the Whiting School or the university as a whole. And the other thing that I want to emphasize is that what I'm showing you today isn't something that's appeared out of the vacuum. We've had a good amount of faculty input over the years from different kinds of divisions, in particular everyone who's participated and is participating in the so-called MCP committee has had great input as we have developed this. And I want to thank all of you for your help and for your input along the way. Let me also there's a couple of pieces of equipment in this, which we'll talk about later, that have been funded through support from HEMI. And I would actually really like to thank HEMI for its support in this endeavor. Now is a good time to do it. So with that, I'm going to pass the baton on to Ken, who will tell you about some of the pieces of equipment we have in it and some of the pieces of equipment that we are going to have in this facility. And take from there.
Thank you, Jonah. I'm Ken Livy, the Director of Operations for the MCP. And so many people know what we have in the MCP, but I want to talk to those people who may not be aware of everything that we do have. So we have some new equipment, and we have some old equipment, and we have some wish list equipment. And so first up at the top, we have recently purchased, that was purchased in 2017, is a Thermo Fisher TF30 TEM. And I was just on it the other day, looking just like that, where we got 0.64 angstrom line resolution, so that part of that microscope is doing very well. In support of the TEM, we have a focused ion beam SEM, Thermo Fisher Helios G4, if you want the specifics of that. And it's really a marvelous instrument. It was delivered at the beginning of 2019 and installed, and all the bugs have been worked out on it. And we have Sam Norris. Sam, would you stand up? He is the newest addition to the MCP. He is our FibSem lab manager, and we're very pleased to have him here. The FibSem is useful for preparing specimens for the TM, but it's also something that we want to expand into the 3D, what's called slice and view collection of data. You get 3D volume data sets on the scale of 50 microns on the side. So it's very high resolution. You can have, it's very large database. That's why we need good connections to computers across campus and into other facilities. And it's equipped with energy dispersive X-ray analysis, so we can do chemistry. It also has electron backscatter diffraction, so we can do orientation and phase ID. The newest piece of equipment that we have is micro-CT. It's RX Solutions. I should say that both the FibSem and the micro-CT, a major part of the funding for those machines came from HEMI. So we were very grateful for the partnership that HEMI has given us in facilitating the acquisitions of these instruments. So the micro-CT came in the beginning of October, right? And so it's now up and running, and we're starting to train people on it. It's fairly easy to use, and it's a lot of fun. You can stick anything that you want in this machine, and it'll give you a 3D view of it. We looked at water. It wasn't very interesting. That's not something that I'm used to looking at. I'm usually looking at something in a vacuum, and this does not have any vacuum. We also have a Deneb materials tester. It's a compression and tension tester. It's a dynamic instrument, so you can squish and pull apart anything that fits the geometry, and we can do continuous X-ray micro-CT imaging on it while it's happening. So it's a dynamic system. So we are starting to train people on the micro-CT, and already we have lots of requests from the medical school. So this is one of our instruments that really brings us into cooperation with with the medical school downtown. So we also have, those are the 3 new instruments that we have. We have other instruments like our JUL SEM that's over in Maryland. I should back up and say that these 3 instruments are in what we call MCP at Olin. So they're in Olin Hall at the moment. And when Steve is ready, all of those instruments get moved over to Steve. So the JUL SEM is still here, but we don't know how much longer that one will go. It's pretty much an old instrument that we have to decide whether or not it's worthwhile to keep a service contract going on that. Then we have XPS that has been maintained a lot by Howard Fair Brothers Group. And we have room for that in the MCP, along with the Auger spectrometer. Is that still, I'm sorry. Maybe I should have put a line through that one. It was pretty...
It hasn't been used for like 4 or 5 years.
Well, okay. So, X-ray pattern diffraction, nano indenters, and a series of sample preparation equipment. There's room for all of this, and then there's also room for future of instrumentation, which everybody has been always asks about, well, what about the aberration-corrected TEM? Well, there is a specific room that is designed for that TEM. And so great care is being taken to make sure that the whatever brand the aberration-corrected microscope we choose will have the best room to enable its performance. So, and I think EYP will address some of that. We will most likely get a scanning electron microscope. That was in the list of the equipment list that the MCP Equipment Committee had developed. And we'll have a new X-ray diffractometer because our old X-ray diffractometer needs replacing. And so everything that's in support of this equipment will be purchased. And also we will be working on designing the best way to port all this massive amount of data that these machines generate off to Marcy or whichever is the best place with new fiber optic lines. We haven't worked out the details of that, but we're working on that. And so I want to iterate that there's great care being taken to create different types of rooms. I don't know if I have it. No. Different types of rooms that will be suitable for extremely sensitive machines, moderately sensitive, and storage rooms and other things like that. So we're creating from redoing the total inside of Steve so that we are making sure that there's no electromagnetic field interference, vibrations, acoustics, temperature control, and we have some really cool ideas of how to do all of that. So, timeline. So, the idea of the MCP has been around for a while, but I want to go back to the time of fall of 2017, and I want you to understand that the way we progress forward in very large projects at Johns Hopkins is that anything that has a major change in the way Hopkins feels, looks, operates, or is a purchase over $5 million, then it has to be approved by the Board of Trustees. So they have been meeting every 4 times a year, and so we can make decisions about what we want, but then it has to go through the Board of Trustees. So everything that we do is basically, what is the next Board of Trustee meeting? What are they going to decide? What are they going to approve? So in 2017, the first approval was the purchase of the Steve Silver building. And after that, then during 2018, there was a series of meetings for the board that said, okay, yes, now you can go ahead and do a feasibility study, get all your ideas together, and then we will approve that. So during 2018, we were figuring out, is it possible to actually have the Steve building as our MCP? In the spring, well, and I want to say also, during that time, we scoped out the building while there were potential interferences across Jones Falls. On the other side, there is a railroad track. And we actually measured the vibrations and electromagnetic fields as the trains were passing by. And they don't have a significant effect on the building. Turns out it's rather complex because of the fact that there's a river and that we're up on a slope and there are all different layers and stratigraphy, that all of those complexities help us and prevent vibrations from getting to us from the trains. Okay, so in spring of 2019, there was an approval for the design of the MCP, which means, okay, did a lot of work, just do it over again. Now this is the final one. So in the summer, we retained EYP for the architectural design, and they were the ones that were responsible for the feasibility test, so they had a lot of experience with that. And now we're at this point where we're having our meeting here. And moving forward, so we have now these Board of Trustees meetings that define our progression forward. So the next one would be in early spring, is that correct?
Towards the end of spring.
May, June.
May, June, okay. For the approval of the build of the MCP. So we can't move faster than the Board of Trustees allow us to. So, and then, so the timeline is construction bidding, so we find out who's got the best bids. And then we begin in fall of 2020 to be completed by spring, summer of 2021. So, do we have any questions about the timeline and that? Okay, so with that, I'm going to introduce Mitra. And she is our director of MCP, and she has the vision.
The vision. Okay, thank you, Ken. Thank you, Jonah. So first of all, hi, I'm Mitra Taheri. I'm just going to be joining the faculty in January, so I really appreciate the foundation that everyone has set up here for the MCP. And as an electron microscopist, one of the most exciting aspects of the MCP is that it's an integration of characterization and processing. So for those of you who are familiar with electron microscopy or characterization in general, whether it be XPS or XRD, a lot of facilities say, let's buy a building, put some fancy microscopes in there, and then that's it. We're done.
Sounds good.
And it sounds good, right? And so while that does sound exciting, it doesn't get us anywhere. And I think what we have an opportunity to do as a community, and that's why these town halls are really important, is to advance electron microscopy, characterization, and processing in an integrated fashion so that we get not only a unique aspect, but we're actually advancing materials processing, biological characterization, high throughput methodologies that I think are what the future is, as well as what can set Hopkins apart. And that's what I'm excited about. And that's what I'm excited about, engaging the community here and allowing us to do that in a really thoughtful and progressive fashion. So, so we're not here to just take pretty pictures. Well, we will do that, I promise. That's not what the vision is. So what I'm trying to get at from the microscopy side, and I'll give you a little background on my end. I'm actually a metallurgist by training, so I have a passion for processing as well as microscopy. But we're calling it intelligent microscopy as far as the characterization aspect of the MCP. And so what would an integrated intelligent microscopy or interdisciplinary center look like? So if you see here, there's sort of these puzzle pieces that can go together. And what it can do is provide a foundation for dynamic environment, a dynamic evolution of materials, of soft matter, in a way that really takes advantage of the strengths of this campus, or really one university, right? So the medical school as well as Homewood. And so what we do is take advantage of strengths that we have in many avenues, and in situ or operando, I think is the word of choice these days. Characterization, material synthesis and generation, where we have strengths here and many walks of science here. Advanced instrumentation, not just in microscopy, but also in processing and other avenues of characterization at the meso and bulk scale. And of course, what has happened in the past few decades is an explosion of artificial intelligence, data science, and machine learning that have allowed us to basically say, instead of taking these piecewise steps forward in characterization and processing, we can turn it on its end. So we can take technologies like adaptive learning, reinforcement learning and things like that, and just say, we're not just looking at a bunch of data sets back at our desk. Let's integrate everything in one step. And what that allows you to do is get orders of magnitude faster, more efficient data, and not just repeat the same thing, because I am not the only one, I'm sure, in this room that has said, wow, I just found this defect, and they found it in 1961. Right? And so we really don't want to do that. Okay? So it's time to basically say, can processing and characterization meet in one place in a meaningful way? And what I'm proposing, and I hope to get feedback from you today, and you know, we've thought a lot about this, is having a data science and machine learning tie to bring those two together in a meaningful marriage. Okay? And so what we've sort of thought of is a threefold foundation. And what it does is take advantage of what the strengths are, or some of the strengths on campus. I, as a new person especially, I'm not really capturing everything that's here, so I really do apologize in advance if I'm missing something, and that's why I'm here. Please educate me. So there's obviously a lot of strengths in materials design and manufacturing. This really kind of is an all-encompassing thing. So this includes HAMI, it includes you know, development, polymeric development, things like that. But of course, I highlight here something that's of interest, you know, of my own interest, which is additive manufacturing. So, so laser processing of materials, extreme environments, things like that. Quantum and electronic materials and devices, again, is a really broad area, but it's a place where we have strength with the Paradigm Facility, Institute for Quantum Matter. And so you're really bringing things together. And this is something that this is, again, taken from my own research, but we really have the ability to not just direct write, watch it, and then later say, let me go back to my desk and watch this movie. You're saying, how can I now do this in a more efficient and high throughput fashion? So we're truly developing on the fly. And actually, a lot of this was born out of the medical and biological field. So high throughput analysis and high throughput characterization has honestly been around for a very long time in medicine. And so we're really borrowing from that and saying, how can we take this high throughput sort of cryo and cell structure characterization and apply it more broadly, not only to medicine, but also to physical and chemical processes. And I think, again, in a place like Hopkins, we have a unique advantage to do this all together in an integrated fashion. So while it's called the Materials Characterization and Processing Facility, we want it really to be a hub for the entire university. And so, ironically, because it's in the Silver Building, it's a nice way to say, can we have characterization and processing as its own sort of boundary? Right, so is this a new next generation boundary that we can say we have on-the-fly processing for? Okay, so I think, again, with this vision, we have an opportunity really to not repeat other centers. You know, I'm sure Ken agrees, we do a lot of road shows. We see a lot of these facilities, and they're beautiful. And some of them have 10, 15, 20. University of Tokyo, I think, has 25 microscopes, something like that. No one's ever going to be able to repeat that here, right? But what can we repeat that's meaningful and contributing to these sort of next generation tools? And so, you know, take advantage of on-campus strengths, and we really think that this foundation, again, in high throughput analysis is the future. So this also allows for us, if we're able to develop new materials and engage in a meaningful way, industry and national lab engagement in a formal fashion. So I think there's a lot of uniqueness here and a lot of opportunity to grow on. So have we thought about who to engage? And the answer is yes. So the MCP could really be kind of a hub for, again, the entire campus, but here's just some suggestions, and again, we're happy here to take more, of what it might look like. So what would a dynamic and engaged integrated environment look like? And what you see here is that obviously we're going to be fiber connected to Marcy, and we have actually already, Mingwei and I have submitted a proposal, for example, with the cognitive science folks and the neuroscience folks to really understand the foundations of machine learning and microscopy and nanoscience. And so we're really trying to engage all aspects of arts and sciences, medicine, applied math, things like that. So next generation manufacturing, when you have on-the-fly processing, you have a step ahead of just 3D printing something and looking at it later. You can say what is happening during the process, right? So quantum science, as we mentioned, and of course, I'd be remiss if I didn't mention, trying to connect in a meaningful way to the Beckman Cryo Center. What kind of high throughput analysis are they doing that we can understand from, and the IMBT. So I think you see here that, of course, HEMI has been playing a critical role here the entire time. Thank you, Katie. And so I think you see here that this is really trying to engage the whole campus and really move beyond what has been a sort of piecewise fashion of characterization tools in the past. So we're really excited about that. As far as externally and external engagement beyond the university and beyond the institutes and centers that already exist, this is just a way to kind of say what kind of federal engagement, locally and globally can we have. So, there are a lot of local companies in the Mid-Atlantic and in the Washington, D.C. and Baltimore corridor that, of course, would be interested in being a part of the MCP or sponsoring in some way. And then we've already had verbal agreements from all of these entities saying, yes, we want to be a part in some way. So I think that when you build these kinds of things, of course, if you build it, they will come, right? So when you say, we're going to do this, and we're going to do this by engaging an interdisciplinary faculty, everyone's excited, right? So as we all know. So I think that this is something that will allow us, too, to have a foundation, both scientifically and financially, to make sure that this is a success and that this is an interdisciplinary success. So we are obviously interested in industry, national lab, other FFRDC type of partnerships, and of course other universities in the area and internationally. So I think that kind of summarizes where we're going. I'll leave it to UIP folks to tell you what's really happening on the ground, not just the cloud vision of what we want to do. So thank you again. I'm really excited to be here and look forward to meet all of you individually that I haven't met yet.
Shall I introduce you guys?
Please, would love to hear
It gives me
this.
pleasure to introduce our UIP team. Some of you in the materials community may know the building at the Material Science Department at Penn State, the Steedle building. I believe you guys, Steidel, I never know how to pronounce their, this is the group that did that, which is a really nice facility. We hope to have something even better here. So let me just introduce the team very quickly. We have Matthew Fickett, Laura Vargas, and Brian Tucker, and they're going to walk you through the plans as they've been developed.
So I just want to add a little bit to the team introduction. Matthew is our specialist in terms of instrumentation and clean room facility designs, and has worked across the country, and he's really leading the effort for the instrumentation suites. And then Laura is a lab planner in our higher education sector. I'm also an academic and lab planner, and we've been helping lead this process as well. I'm just going to kick this off, and then I'll turn it over to Matthew and Laura. Just to orient you all a little bit, this is kind of two buildings at Steve. The larger side here is what we're calling the 70s building. It was built as kind of a big factory warehouse when it was a functioning silver facility. And that's where the instrumentation and lab rooms will go. It's a very solid foundation. We're talking about foundations. We've done a lot of the testing for this area in terms of vibration, and it's a very solid area for the instrumentation suite. It also gives us the ceiling height that we need on this side of the facility. The other side, which is in the 1928 building, the historic building, is going to be the office suites and team and meeting areas. And then we are connecting, as part of this project, these two areas. So you'll be able to go from the ground level of the 28 facility directly in